This is main effect, okay? So what would beta hat be? Should we write down what beta hat would be? Here? So beta hat is going to equal what? In this case? How would I estimate it? I subtract, so this is actually a number, right? This is an observation. What is this? This is the effect you saw in what?
Run 1.
Run 1. Okay? So it would be run 1, negative run 1, plus negative run 2, plus run 3, plus run 4, minus run 5, minus run 6, blah, blah, right? So this is a way of being able to just take these runs, okay? We've designed what these runs look like. I told you what each run looks like. In run A, I did use what? I used low for factor 1, low for factor 2, low for factor 3, right? In run B, run 2, I used high for factor 1, low for factor 2, low for factor 3, right? And so this is specifying what I'm using in each of the runs, right? If you think about your helicopter wings, right? Or your helicopter flying, you would pre-specify which of the combinations you're using, okay? And each of these runs we're going to compute, I don't know, how far the thing flies, right? Or yield of corn, okay? And then I'm telling you, if you add them up the way I told you to do here, right? You're going to get an estimate of alpha. You're going to add them up the way I told you here, you're getting your estimate of beta, okay? That's what it works out to be, okay? Yeah?
So each one is 1 or negative 1, and the sum of the columns is 0. Why is it alpha beta always equal to 0? That's an assumption we made.
Because these are, okay, so these are not all the same, right? So we're not adding up the 1s and 0s. The 1s and 0s are giving me the signs. So let's, I'm sorry, I should have been more clear about that. Right? They're giving me the signs in front of the y's. Okay? Is that better? So if the y's were all equal, right? If all of the runs were equal, what would it mean? It doesn't matter what combination you use here, right? So then it really would be 0 or near 0. Okay? But if some of these are different, according to the pattern that we have specified here, with things being high or low, right? So if we look at this one, okay, what's this pattern saying? This pattern is plus, 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 plus here. Wherever it's a plus, it's because we're looking at the 2, the higher one, right? So if this is really positive and away from 0, what does it mean? It means, you know, the second one, right? Second higher level of factor 1 is giving me more yield. Okay? And this is just telling me how to add or subtract these ones. Okay? So all this design is doing is just rewriting what we've done before. And that's what happens when the thing is full. Okay? Yeah? Or no? Okay. Yeah.
So is this table used when you start to get to higher number of ANOVAs?
Yeah, this is what you use when you get to higher number of ANOVAs. If I ask you to do like a 5-way ANOVA, right? You're like, I can't, you know, do all of those runs. I don't have, this is what you start using. And these patterns of plus and ones, people give this to you. And the idea is to hopefully give you one that lets you capture the low, you know, at least the lower order interactions, but maybe not the higher order. Okay, so these are pre-specified. Okay, there's a professional business designing these. Some people use ideas from Sudoku to do it. Crazy enough. It actually is kind of interesting. Okay, so in this case, we can, okay, it's the same story. This will give me an estimate of A, right? This will give me an estimate of what? My main effect for A. This will give me an estimate for what? B. Okay? It's a little bit lacking because you got 2, 2, right? 1, 1, but you're ignoring some of the other terms, right? Unlike the other one, which had the full term. But what did we learn about our estimate of the main effect here for A and the estimate for this interaction term? What's true about them? They're confounded, right? So you can't say something about this and this. You can't tell them apart. Okay? That's the problem you start having there. You can still estimate them, but they are confounded. Okay? Because you haven't done enough experiments to be able to tell those apart. Okay, so that's yeah.
Sorry, is that basically saying you can't tell whether A or B, C is having the effect?
Exactly. The effect might be from A, it might be from BC. I can't exactly tell you. That's exactly the state. Okay? So it might be the main effect A, it might be the effect BC. I can't exactly tell you. That's why I call it level 3. Because we just kind of say it's some combination of these two. Okay? So that's what's going on in terms of an explanation. Okay? We'll do a higher order example now? Okay. This is, we have now ABCD, right? So okay, let's walk through this. Why is it 2?
You have 2 levels?
2 levels, right? Okay. Why is it 4?
4 factors.
Beautiful. Why is it 1? Because a quarter of them are gone, right? Is it a quarter of them? Or half. Thank you. Someone's awake. So, how many should there be? Yeah?
Oh, I think they have to know.
How do I know? What is this number? 2 to the 4th is? What do we have here? 8, right? 16 divided by 2 is 8. 2 to the minus 1 gives us that half, okay? So this is really telling, hey, how many of them am I losing? Okay? Okay. So let's talk about this, okay? Now, same story. All minuses, A, B, C, D, all low, high, low, low, high, blah, 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 right? You gotta check these all add to 0 in terms of the pluses and minuses. So my main effect would be, what would my estimate of the main effect be? It would be this minus this, this minus this, this minus this, this minus this, right? Add all that up, divided by 8. And if I look at this, right, this is just, each of them, this is high on the first one, low on the second one, right? So that's why we do the subtraction this way. High on the first one, low on the second one, subtraction, right? Just everything I told you before, okay? So now, what's the first thing I'm going to have to figure out here? First question, are there any identity columns here? No, right? So we can't just look at it and say what's the generator. So in the previous one, in this case, I could actually look at the generator. I could just look at this, right? And say, what's the generator? It's ABC, right? Because it's got all ones, right? It turns out here, I can't just look at this and find the generator. So what am I going to do? What am I going to look for now? Confounds, okay? So let's look for confounds. Anyone see a confound? So you said D and ABC are a confound. Yeah, exactly. D and ABC are a confound. So can you tell me my generator now? My generator is A, B, C, D, okay? And we know what? You said D and ABC are a confound. Okay, so what do we know at least the level is going to be what here? The level is going to be at least what here? 4, right? We know at least it's level 4. It might be lower, let's look, but at least it's level 4. Okay? So if you see that A, B, C, D are confounded, right, and D and A and B, C are confounded, there should be other confounds. What do you think, just looking at this, right? What are the other confounds you should be able to find? How about AB and CD? Do you think those should be confounded? Should we check? Let's see. Here we have AB. We don't have CD in our table, but could we compute CD?
Yeah.
Yeah, right? We can. Are they confounded?
Yeah.
Yeah. Minus minus plus, check. Minus plus, check. Check. Minus minus plus, check. Plus plus plus, check. Plus minus minus, check. Plus minus minus, check. Plus plus plus, check, right? A, B, and C are confounded. What are all those compounds going to be? A and B, C, D, right? We could do this for hours, well maybe not hours. Right, so these give me my compounds. So A is confounded with BCD, B is confounded with ACD, C is confounded with ABD, D is confounded with ABC, AB is confounded with CD. We can go on, right? And ABCD is confounded with the mean. Okay? Order 1, 1 plus 3 is 4. Okay? So sometimes we write 2, 4 minus 1, 4. We write the level below. Okay? Okay, so So the other thing you can do is you can pick the generator and then you can come back and do the confounding design. Okay? But let's not worry about that so much. We're not going to do that to you, okay? What we would do to you is we give you something like this, right? Okay, what could I do to you regarding this? What could I do regarding this? If I gave you a picture like this, right? What are things I could ask you? Find the generator, right? Find the generator, find the confounds, right? I could ask you how to estimate any of the effects, right? I could ask you which of these effects are going to be confounded, right? What else could I ask you? I could ask you the level, right? I could ask you to classify the design, right? This would be 2 to the 4 minus 1, and what would I put down here?
4.
Roman numeral 4, right? So these are the types of things I could ask you. Okay? Should we do one example and then you guys can evaluate? Okay, so I guess we'll start. We started with concrete, right? We'll end with concrete. There's something very, I don't know, really personifies this class, concrete. I'm joking. Yeah. So as far as I know, at least when I poured out concrete, I had, you got water, you got mixing stuff and gravel and cement, right? And you can vary this. I never knew what goes in the mix, right? I guess we don't need to worry about that. Okay, so we did 8 runs, okay? And what are we measuring here? What are these numbers? 21, 23, 27, 24, blah, 37. What are these numbers?
Inches? No. That's too high.
What is a slump test? Has anyone ever done a slump? Yeah.
Yeah. You put concrete into a standard size cone. You slowly take off the cone and you see how much that amount of concrete droops down, and you measure the number of inches.
Yeah, it's like the drooping of the concrete, right? You put it in a cone. I actually didn't know you put it in a cone. But yeah, basically you're putting your concrete into something, take it off, how much it droops. That's how much it slumps, right? So this is telling us, right, if we use the lower level of A, the lower level of B, lower level of C, and lower level of D, right, it drooped 21, I guess probably inches. Or maybe millimeters.
Maybe millimeters.
Yeah, millimeters. Inches would be bad, right?
Yeah.
That might be bigger than the standard cone. So.
The cone is like 2 feet.
Yeah, I think inches might be impossible actually physically. So let's say millimeters, okay? Okay. And so what are we going to try to work through? What are the things we can first do? So do you want to first estimate the effects, or do you want to first work out the confounds? What do you guys want? You guys want numbers first, or confusion? You have a choice. Okay, these are my numbers. Okay? So, if I add everything up, that gives me the main effect. Right? I actually forgot to tell you this, okay? If you add everything up, that's the main effect, plus all of the interactions, the highest order interactions, okay? Now what is this? You've seen this pattern before, right? Minus 1 plus 1, minus 1 plus 1, minus 1 plus 1, minus 1 plus 1, divided by 8, right? Shoot, I should have not shown you this, okay? So typically, what is this? A hat, right? Why did we write it as A hat plus BCD?
It's confounded?
It turns out that, yeah, it's a confound, okay? So let's go back and look at the confounds, and then we'll come back to this, okay? So first let's look for a confound. So, do you see any confounds here? A and A, or is it A and ABC? B and ABC, right? No, you're right, D and ABC, right? Okay, so let's write this down. You really wish you had like one of those scanning things, like Scanatronics, right? So you have D and ABC are confounds. Okay, so what's my generator? I is equal to ABCD. Okay, so now do we have an idea of what our subconfounds are? Confounds are, right? So A should be confounded with what? BCD, right? And I think that should be true. So if I multiply all of these together, I get what? 1. Right? If I multiply plus, all these together give me? Plus, all these together give me? All these together give me? We can do this, right? So that's one of my confounds. A is confounded with BCD. And that's what we have here. A and BCD, these are a confound, okay? B is confounded with ACD. We got that number there. And C is confounded with ABD. Okay? This is a number, and this is with AD and CD.
Why are we adding like A?
Why do we add them? I'll get back to that in a second, okay? And so, again, what we're getting here, okay? So let's write this down. Okay. So here you have an A, right? You're good by that, right? Do you see a BCD? Is there a BCD column? No, right? So what we got from here, we could have gotten from A, or we could have gotten from BCD, right? And we say we don't know which one it came from, right? So it came from some linear combination. It came from an additive combination of both of them. So we're making an assumption, right? We're assuming that these factorial are adding, right? That the confounds are adding. And that's why we said plus. Okay? If they're multiplicative, all bets are off. Okay? And so same here. As you know, A has a confound with BCD. Correct? So you don't have a BCD here, right? Because it's a confound, you didn't need to write it down, just by design. And so that number you got is from it's either from A or from BCD. Okay? What happens if the following? What happens if you really want to know what the main effects are? What might you hope? You might hope that the interaction effect is lower, right? And then one thing you could do is then you can do another design to study that, right? once I know which of these subsets are relevant, I can go back and I can do a design with fewer variables. Okay? So that's one of the things sometimes you do. You first do this, you get something, you have confounds, but then you can do another test to get rid of those confounds. Okay? Let's talk about one more thing, okay? What level is this? I think it's 4, right? Because it's 1 and 3 or 2 and 2. Those are my confounds, okay? Okay. Do you want to do one more example, or do you want to do the what are they called?
Evaluation.
The evaluations? Okay. Do you think you can do your homework now?
Yeah.
Yeah? I think I explained, the reason I explained it mechanically first is that you can do it as pattern matching and just you can see what the patterns are, but I think it's easier first to, if you know how to manipulate the thing, then explain why you're manipulating it that way. Okay? So, I'm going to pass these out.